Hello guys, welcome again to this tutorials, and today we're going to look at vectors and transformation. My name is Samuel D. Koidia, and I want us to go along as we move to the very important topic. This topic is very necessary for grade 10, 11, and even 12. And those of you doing the West Africa examination, that's the West Africa Senior School Certificate Examination, as WAS, and whether you are doing it with the general population or you're also doing it privately, no problem. So you get to do through all of that. This is vectors and transformation, and today we want to look at what is a vector. So a vector is a physical quantity that is specified by both magnitude and direction. Remember, when we were doing physics, we said that the universe have measurable quantities, and the measurable part of the universe is what is called the physical quantities, and we extended that interpretation or discussion based upon vectors and scalars. And scalars, we said, they are just numbers. So today we're going to look at vectors. What's a vector? A vector is a physical quantity that is specified by both magnitude and direction. So now we are going to first of all look at a vector in a plane. So vectors can be represented by either a small arrow on top of it, that is a position vector, or you can also represent it as a capital letter, and we can put them in, and each vector must have a component along the x and a component along the y. So let's say this vector is described within the horizontal direction, that is the x component of it, and we have that vector in the form of the vertical component of which is the y. And this form of a vector is what we call the column vector, the column or matrix form of the vector. Matrix form. I can also represent that vector in another form. Maybe I've represented in this form x, y. So it could be the x component and the y component following in that order. So now we have the coordinate form of the vector. This is the coordinate form of the vector, or also called the rule form of the vector. So the vector can be in this form. You can represent them in this form because it can be acting in that x plane, also acting in the y plane. So the two components form the vector there. So let's say the vector A, it's described by the coordinate x and y, and we want to know the magnitude of the vector. So what's the magnitude? We say is the size and also the length. You can also refer to it as the size or the length of the vector. So how do we find the size of this vector? So we look at the magnitude, that is where the magnitude comes from, here. So we can represent it in the x and y planes. Let's say I want to represent this same vector in this plane, x plane, from the origin. So it's going to be there, and that. So let's say that is vector OA. So OA, so that is its component in the x. So let's say that's my vector A, which is x comma y. So I've represented it there, and the length of that vector tells you the magnitude of that vector. And we also want to know how it is orientated towards the x-axis, which gives you the direction of that vector. So I'm blending the two together. I'm putting the magnitude of the vector and the direction. Remember, I told you the vector is a physical quantity that is specified by both magnitude and direction. So now we look at examples of those vectors. So we can say example of a vector. Example, it's a force. The force can be a vector, and we also know that acceleration is an example of a vector. Yep, we know that weight can be an example of a vector. Yep, displacement can be an example. So all of these are physical quantities that are specified by both magnitude and direction. What's the magnitude? It's the size of that vector that is referred to as the magnitude, or also the length of the vector. And what's the direction? The direction is the way it is orientated. So now we look at how we are going to find the magnitude. How long is this vector? What is the size of this vector? So the magnitude of that vector, if you want to say, that's the same vector, the magnitude can be in that form. So this vertical line means the magnitude of the vector can be given as x squared, that is the component of the x-axis squared and the y-axis squared. It gives you that. So let's say this vector was 3 and let's say 4 and 3. So we have 4 and 3. So, or it could be also the form 4, 3. Yep, so now if I want to represent that, this is the 4, the magnitude of it here in this y-x plane is going to be 4, and the y there is 3. So let's say that's an example of that vector with its dimension, with its orientation along the x-axis 4 units, and the y-axis is 3 units. So now we want to find the magnitude of that vector. It becomes, this is the formula, this is 4 square plus 3 square. So I can have, this is 16 plus 9, this is root of 25 here, and which is 5. So the magnitude of this is 5 units. So from the x was 4 units, the y was 3 units according to this description. Now we want to find the magnitude of this vector, which is the size of the vector. How long is our vector? That's the size of it. So, but we want to know what is the orientation of this vector with respect to the x-axis. That gives you the direction. So the direction, which is given by theta, that's Greek symbol, which is this signifies direction in this case. It's actually giving us the tan inverse of y over x. Remember here it is not x over y. Remember here the coordinate system, the x came before the y, but here it is the y over the x, because we want to find the, if you wanted to find this angle here, this always forming a right angle triangle. So that right angle triangle, let's say here this becomes theta, so it was going to be x and y. So it is opposite over adjacent. That's opposite over adjacent is 2. That is 2, which is tan theta is equals to the opposite all over the adjacent. So the tan theta is going to be the opposite of this, was the x component of that vector, which is the y, and the x was that. So if I want to find the theta, it's going to be tan inverse. I divide both sides by that, tan inverse of y over x. So now we have the direction of this vector. So the direction of the vector is given by that component. So we have these units. This is the magnitude, so the direction. So we can find the direction from this example. The direction from this example is going to be the tan inverse of what was the y component there is 3, and the x component is 4. So if I have theta, this tan inverse of this is 0.75 if you like. So you can have theta as equals to 36.7. If you press that from your calculator, maybe you get something around that. So we get approximately, let's say 37. Yep. So we just approximate it. So if you use your calculator properly, you'll be able to get a correct answer over here. Just approximate it for you. So now we have the direction, the magnitude of the vector given by this formula, and the direction given. So two important formulas you have to take note of is this guy here and this guy here, this equation 1 and this equation 2. So that the most important two equations I've given to you. So you now know that a physical quantity that is specified by both magnitude and direction is what we refer to as a vector. And an example I gave you was the force and acceleration, the weights and stuff like that. We all give you a vector. But we want to know the magnitude of the vector. How do we calculate the magnitude of the vector? And to be precise, just find the Pythagoras Theorem here. Remember, if you want to find Pythagoras Theorem, which is the magnitude of this vector, this is, let's say, the magnitude of that vector A was supposed to be, the magnitude A was supposed to be the square root of that and y square. So it came from x square plus y square, which is Pythagoras Theorem. So in other words, this magnitude is always the Pythagoras Theorem, and the direction is always the theta, the tan inverse of the y over x, that is the trigonometric tan of that angle. So you look at these two. So the next thing we want to look at is when an example, for instance, I have the bearing of a vector. Now I want to find the bearing of the vector. So I want to find the bearing of a vector. Yeah, I've found the direction. Let's say that's the direction of the vector. Now I want to find the bearing of this vector. So the bearing of the vector, it's the clockwise angular. You know that bearing is always clockwise angular measurement. It starts from the north pole. It's clockwise, starts from north pole. Yep, so now I want to find the bearing of a particular vector. Let's say I have a vector A, C, here, which is -7 and 12. Here, this must be one of your questions. So now, if the vector AC, which having the magnitude of that, which having the composition of the x-axis there. So if I can put it right here, I have this. This is minus 7 somewhere there, and I have 12 somewhere there. This is y. So I can represent that vector. It starts from A, so that's A somewhere there, and it goes up to C. That is C in that case. So I'm moving from A to C, and I've got this magnitude there. The component of the y is 12, and the component in the x dimension it's minus 7. Minus 7, that's why I went this way, because this minus is 0, this is positive x, and this negative x, so I went the other way there. So now we have this. Now we want to find this angle here between the two of them. So now if you can punch this from your calculator, you can find the theta as equals to the tan inverse of y over x. Remember that this is theta is equals to tan inverse of the y is 12 all over 7. Now I eliminated the minus because it's giving you, it's going to find the direction. I've already solved for the direction because I've given you the component in the x-axis, and that tells you it in the negative x. That's telling you that I've taken care of the negative already over here. So I've just put it 2. So I have theta is equals to, now if you punch this from your calculator, maybe you will have tan inverse. Theta is going to be tan inverse of something like 1.7. So if you punch that from your calculator, you have 59.6. Let's say approximately you have 60 degrees there, and that is the direction. Now we want to find the bearing of that vector. So if I want to find the bearing of, so the bearing of C from A, it starts from the clockwise. I start from the north pole, then I move clockwise. All of this is the bearing. So I start from this north pole and I go clockwise. I said bearing starts from north pole and goes clockwise. So if I want to find the bearing of C from A, I must start from the north pole of A. Then I go clockwise until I touch the line going to C. So now all of these is supposed to be the bearing. So I found this angle already, but from east, this is south, and this is west. So from north to west is already 270. So I have 270 degrees plus, and I also have this my angle here, so that is 60 degrees there. So you can now see that this is going to be 330. So the bearing of C from A is 330 degrees. And bearing starts from the north pole, remember, and it goes clockwise there. So I found the bearing of the vector. So two things I've said here. I found the magnitude, I found the direction, and also the bearing of the vector. So watch out how to find the bearing of the vector. You find the magnitude, you find the direction first, and you find that angle, and you know that bearing always starts from the north pole and proceed clockwise to be able to do that. So now let's proceed as to move ahead with the next thing we want to know is what are the types of vectors we can interact with. Vectors can be parallel and vectors can be also perpendicular. So what is that form of vector called a parallel vector? So I just give you an example of vectors being parallel, also perpendicular. So watch out for this. Now we have the first is, now I want to find parallel vector. So I say parallel and perpendicular vector. Now, two vectors are said to be parallel if one is a whole number multiple of the other. What do I mean by that? If the scalar multiple of one is equal to then if the vector is a scalar multiple of the other, then the two of them are said to be parallel vectors. So, example, I have a vector A. If I say I have a vector A, 2 and 4. So it's the component of this vector in the x is 2, and the component of this vector in the y is 4. Now I want to find a vector that is parallel. So if the vector has to be parallel, we find first of all the whole number multiple. What's the multiple of a number? The multiple of a number is that number that is derived when that specific component is multiplied by an integer. So if I multiply this by an integer 1, I will have 1. Let's say 2. If I multiply this by 2, I will have this is 4 and 8. Then what I did was to multiply this by this, I got a 4, and 2 by this, I got a 8. So since this vector is, let's say this vector is P, so if this is a whole number multiple of this vector, then we can say that A and P are parallel. They are parallel vectors. Yeah, because one is a whole number multiple of the other. And now this because the multiple that I multiplied was 2, and that is, I multiplied this vector by a plus 2. The integer that I used to get this vector here was a positive number. So this vector is parallel and they are in the same direction. When they have when you have the integer being a positive integer and this integer multiplied by this gives us this. So it means that the two vectors are in the same direction. So conversely, let's say I have a vector Q, and Q is 3 and minus 3 and let's say 3 and 6. Now I want to find R. So if R is now minus 6, then I have and then a minus 12, minus 6 and a minus 12. So how did I get R? I multiply here by a minus 2, so it is 3 times minus 2 give you a minus 6 over there, and 6 times minus 2 give you minus 12. So this and this are parallel. They are parallel vectors, but in the opposite direction. Because the whole number multiple is a negative number. When the whole number multiple is a negative number, then that vector is parallel, but they are in opposite direction. So that is the two forms of parallel vectors you can see. If the whole number multiple is a positive integer, then it is a parallel vector of the other, but they are in the same direction. And when it is a negative number, they are parallel, but they are in the opposite direction. So watch that. Now we have the next what we want to look at is a perpendicular vector. What is a perpendicular vector? A vector is said to be perpendicular if it is rotated. So now we can look at this. So for perpendicular vector, so we have perpendicular vector. So we've done the parallel vector. Now we want to look at the perpendicular vector. If it's a vector is said to be a vector is said to be parallel. This is said to be perpendicular. Sorry, it's said to be perpendicular. So when rotated at 90 degrees and 270 degrees. Yeah. So when I rotate the vector 90 degrees and 270 degrees, then it's going to be perpendicular. For example, let me just look at this example here. Now, if the vector is standing this way, let's say it's a bottle. So I put a bottle somewhere there, here. Now I want to rotate this bottle. I want to drop it perpendicular. Perpendicular means that this is there, and that is standing. So it was standing like this. Now I have dropped the bottle, rotated it 90 degrees. This is perpendicular. This is 90 degrees there. So the bottle is supposed to drop in this direction. So let me give you another ink here. So you have that. So this, when the bottle drops this way, so I have rotated it 90 degrees here. It was like this. So I have dropped it there. So it became 90 degrees. So when I rotate it that way, then that vector is going to be parallel, is going to be perpendicular because it is now rotated 90 degrees. Conversely, I can also drop it the other way there. This one can drop the other way. So let's say now the bottle drops this way. I have something like this here. Yep. So now this bottle has now dropped the other way here. So in that case, I have moved it. This is north, this is north, this is east, this is south, and this is west. So I have dropped it 90 degrees. That's 90 degrees here. So there. So it's 90, 90. I've dropped it 90. Then I'll also drop it 90. This is 90. Then now 90. So I have dropped it there. That is 270. So when I rotate it 90 degrees, then it becomes perpendicular. That's what will happen here. Yeah. Or I rotate it 270, becomes perpendicular also there. Perpendicular is right angle there. So that when I want to find the perpendicular of a vector, then I have to rotate it. Then how do I rotate the vector? I'll rotate it here, 90 minus x in that case. Now, and this 270 is you either run this one 3 times, or you also have minus y comma x. So now either you rotate this anti-clockwise. You see, if I rotate this one anti-clockwise, I get that stuff there, or I rotate it clockwise, I get this one here. So now I want to now see how I can get an example of a vector that is being perpendicular to the other. So let me just give you an example of the two. So 2 example here. The first is I want to now find the perpendicular of this vector. So here, find the perpendicular vector to this. So let's say P is 4 and 6. Now I want to find the perpendicular to that vector. So I said it could be, let's say, perpendicular 1. I have to rotate it 90 degrees. If I rotate it 90 degrees, it's going to be I'm supposed to bring the y, that's how I bring the 6. Yeah. Then I'll bring the x and put a negative, so it becomes that. So this is either this, or I want to also rotate it 270. 270 says bring the y, so I'll bring the y. Let's say P2, just bring the y, put negative there, so I put minus 6, so we're there. Then I bring the x without touching, that is 4. So it is either I rotate this 270, or I rotate it 90 degrees. So when I rotate it 90 degrees there, then I rotate it 270, so I can find the perpendicular to this vector is either this, or this. So that is the way you find the perpendicular of the vector. So watch out for what I have said so far. I have been able to give you the difference between the parallel vectors and the perpendicular vector, and I've given you the direction based upon the whole number multiples that are, or the scalar multiple that are going to give you that the parallel vector, whether in the opposite direction or the same direction. So now we proceed. Follow up as we move. Now we have got the direction of the vector. We have got the magnitude of the vector. So it's possible that also you will be given a way to map the vector, mapping the vector. I can map the component of the vector, mapping vectors. Here I can map a particular vector. Let's say this vector is x, y. I want it to map it such that it becomes x and have half of x plus y, something like that. So I got to map this into that. So I can map vector p. Let's say vector p is 4 and 6 again. Here I want to map it there, so that mapping is using this condition. So it tells you, say, bring the x, that's the x over here, that's 4, that's the x there, this is x and this is y. So you say bring the 4, and now bring the same 4, which is the x there, this is 4 divided by 2, that is the x somewhere there, and plus, then you bring the y is 6, that's 6 over there. So now when I map it, I'm supposed to now have, this is going to be, this gives me 4 for x, and this is 2 plus 6 gives me that, and this gives me therefore 4, and this is 8. So when I map this vector, under this mapping, this vector now becomes, if p was this, so p1, the first mapping, is supposed to be 4, 8. Right, so I've mapped this vector using this mapping onto that. So you can also map vectors as you move along there. So just follow up as I'm moving. This is mapping of vectors. Now we move again quickly with how we get the. Yes, so I hope you're following. We go together. Now we have found the magnitude, we found the direction, we found the bearing, and we also found the mapping of the vector. Now we want to move a little bit fast, so watch out. Now the next thing is to actually find the midpoint of the vector. So I'm going to look at the midpoint of the vectors. The midpoint of vectors, or the vectors. Here, so I have a vector A, let's say it's with coordinate x1, y1, and vector B, let's say there's another position vector here, x2, y2. Yeah, so this is, now I want to find the middle of that vector. That's the midpoint of that vector, m, and that's m of that vector. The midpoint is supposed to be the average of all the x components and the average of all the y components. So here, so this gives you the midpoint. The midpoint is given by that. It's midpoint, the midpoint of that vector. So now, for instance, I want to find example here. Here, let's say I have vector p. P is 3. P is 2 and 4, and Q, vector Q is 4 and 8. Now I want to find the position, I want to find the midpoint of this vector. This is the force, so it is PQ. Example, let's say in PQ, so you can find that line PQ, I started with P, so this one is x1, y1, and this is x2, y2. So now the midpoint is going to be, the midpoint gives me, this is the x1, this is 2 plus 4 divided by 2, and we'll have 4 plus 8 divided by 2. So this 2 gives me that. So now I have, this is 6 divided by 2, and this other guy is 12 divided by 2. So now if I want to find the midpoint, it's going to be 3 and 6. So the midpoint of this point is going to be the midpoint of P and Q, line P and Q is given by 3 and 6. So you must be able to look at the thing. Now we have done the magnitude of the vector, we've done the direction of the vector, we'll be able to look at the bearing of the vector, we have mapped the vector, so we want to look at the midpoints. Now we want to manipulate properly, much more, so watch out for this kind of question. So you look at the manipulation of the vectors, we look at manipulation of vectors, so we manipulate for adding, so the force we adding, we are going to add addition and subtraction of vectors, subtraction of vectors. So remember, I just told you that it is easier to interact or manipulate the vector based upon the position, based upon the Coulomb form of the vector. So the Coulomb form of the vector, it's easier for the students to manipulate the vector properly. So the first manipulation is we want to find the addition of the vector. So let's say we still have this vector. This vector is x1, y1, and vector b is also x2, y2. Now this is the first position, this is the second position as a matter of fact. So now we want to find the a plus b, that's the adding of that vector. So I can have a is x1, y1 for that guy, and also x2, y2. So if I add corresponding x and y. That's how we add vectors. We add vectors by adding the corresponding x and the corresponding y's. So we have that. This is the same goes for subtraction. If I want to subtract, I have x1, y1 minus, this is x2, y2. So I subtract corresponding x's and corresponding y's. So I have y and y2. So when you manipulate the vector, you have added, so adding and subtraction. So I have added them here. Now, so we can also go to the third manipulation. This was addition, if you like. This is addition. So this is the first manipulation, and with b, which is number 2, is subtraction. Remember, so we subtracted. Now we want to also multiply by a scalar. This is just a number. So if I have a scalar, let's say multiplying the vector by a scalar, multiplication by scalar. A scalar is just a number. Yes, for instance, I just say I want to find now 2a. So if I want to find 2a, the scalar there is 2. So I have 2 into, that is a is x1, y1, in that case, x1, y1. So this is 2x1 and 2y1. So what I'm doing here is just to multiply the scalar by the vector itself. All the components of that vector must be multiplied by that scalar right there. Then that is what we call multiplying the vector by a scalar. Now the fourth manipulation is equating the vector. We want to manipulate equating vectors. Yeah. How do we equate vectors? Now, by equating vector, if I say A is equal to B from this same example, it means that this vector here, x1, y1 is equal to x2, y2. So if that's the case, then you can also say now that in that case, x1 must be equal to x2 and y1 must also be equal to y2. So have manipulation number 4. So we have the 4 manipulation. I added the vector, I subtracted the vector, I multiply by a scalar. Now I want to equate the vector. So for instance, under this, you have November 2001 question. I remember this question. It says that if P plus 1 and Q all is equals to, this is 3, 5 minus P. Now it's a find the values of P and Q. So in November 2001, if you can recall that question, you find out that if in this concept, this equating the vector, you use it over there, you now know that it is the x component of this guy here must be equals to that component over there. So now P is equals to 3 minus 1, so P equals to 2 there. And I come back to the y is Q, this y, go with that stuff. So we have Q is equals to 5 minus, remember this is now 2, so Q becomes 3. So if you put this in perspective, you find out that if I put 2 here, if I put 2 somewhere here, so 2 plus 1 gives me 3 over there, and if I put 2 here too, this is 2 will give me this one is 3. So Q is 3. So if you subtract the 2, you find out that they are equal. So that is how we equate the vector. Now so that is just an example. So we've done addition, subtraction, multiply by a scalar. We also done the equating the vectors. So now we move a little bit. So we have done the manipulation. Watch out for this. Now the next thing we need to know is to actually find the, let's say it's also 2000. I have an example here, another example. Now you have been given, let's say x is given. If x is, let's say 3 and 4, watch that, and y is, let's say 5, 2 and 5, that's 8. So now I want to find, they say find the magnitude of x plus y. Remember that? So if I have stuff like that, I can now find x plus y first of all. So this is adding, I'm adding that, so it's 3, 4 plus. I go back there, this is 2, 5. Now so we have 5 and 9. So 5 and 9, this is the x component, this is the y component. But this question says find the modulus. The modulus is the same as the magnitude. So remember these vertical lines I told you when I started my lecture, but the vertical lines there means that the modulus of this, and the modulus of that vector, this vector now is x plus y modulus is given by root of x square plus y square. So remember you already have the x over there, this is 5 square and this is 9 square. So you now have, this is 25 and this is 81. So you must be able to now have 106. So you root that stuff, that answer gives you the magnitude of this vector. So remember, they can give you this stuff to tell you that this is the magnitude of that vector. Watch out for that question. Now I can take more manipulations here. Let's say I have example 2. I have a vector A. Vector A is 3 minus 4, and I have a vector B, which is 4 and minus 6, in that order. Now I want to find, let's say find Roman figure 1 is 2a plus 3b. I want to find that, so I'm multiplying, I'm using 2 of the manipulations there. I'm trying to add, I'm also trying to multiply by scalar. So I go with 2 into a is 3 minus 4, then plus, this is 3, then b is somewhere there, that's 4 minus 6. So I go with that, this is 6 minus 8. Remember what I did here, this plus, this is 12, and this is the same as this one, multiply that to give you minus 6. So let me just remove this. So I have that, this is minus 18, this is minus 18. So I remove all of this, so that is, I simplify it somehow. So now here, now how did I get this negative? This is 3 times 4 is 12, but plus times minus is minus, that's how I got that, and 3 times 6 is 18. So I have 18 somewhere there, and I have minus 26, this is minus 26. So I have this vector, and it's giving us minus 26. So that is how you manipulate the vectors, and the vectors can be manipulated as I'm moving along. along there. So watch out for this serious manipulation. So watch, this is magnitude and direction of a vector. Now I want to move forward with another example. Watch out. Now we have already done the vector introductory part of the vector, so I can now move with the position vector. Watch out for the position vector. This is position vector, this is position vector. Now for position vector, there is relative to the origin. The position of the vector is relative to the origin. Position of a vector is relative to the origin. And what's the origin of that vector in the space? It's going to be there. This is 0. So now we want to look at the vector. Now let's say I have a plane. This is x and y. Now I want to, this is the position, this is the origin of the vector. X is 0 here. That's the coordinate frame. So now I want to find the vector A. This is A. And I want to find the position of this vector. So this is vector OA, it's in that plane, let's say there. And I have another vector somewhere there. This is B here, and I have here, this is O, remember here. So now I can also find here, let's say it's a parallelogram, again, another vector, this is C. Now I have there. Now we want to find the position of these vectors relative to the origin. So the position of vector A here, it's point A, that is the vector, this is the point, its position vector. The position vector of vector A is OA, this is relative to its origin, and vector B is OB. Yeah, and now if I want to find the position vector of C, vector C is OC. Just put the origin because it's respect to the origin. And if the vector is in that plane, then we can also look at the relationship between this magnitude here, OB and OA. So we always interact the vectors by triangle addition of vectors. Triangle addition. The addition rule. See, in addition rule, the head of one vector, head follows the tail. We call it the head to tail principle. So if I'm adding this vector, I have to ensure that the head of one vector follows the tail of the other there. This is vector O there, and this is point A, and this is B. So if I want to find this vector, let me color it. So I want to find the blue here. So for finding the blue, OB, this is that vector OB, is supposed to be equal to OA, yes, plus AB. So I have maintained the rule that is the head of one vector follows the tail of the other. This is there following the tail, is the head follows the tail of the vector and gives me this vector here. So the head of one follows the tail of the other to give me this vector. So now if I want to find this, I'm going to find AB as equals to, I've moved, this is OB minus OA. So in summary, you can see that if I'm coming to find the position vector of AB, then it means that I must move from the back here is OB minus OA, just to be precise. It came from this structure. So if I now want to find the position vector of PQ, so I can also say, okay, therefore, if that is the order, with this order, I can now say is OQ minus OP. Yeah? If I want to find, if I go back this way, I want to find BC the same here or here, this is the same, so OC from the same triangle, so I will bring that same triangle out here. This is it, this is C, and this is B, and this is TO, this is these two go, so I'm going to find that. So if I follow the same rule, the head of one vector follow the tail of the other, the head of one vector follow the tail of the other to get this triangle. So I can now have, therefore, OB is OB, that is this, is supposed to be OC, that's OC, now plus CB plus CB. So you can now make CB the subject of the formula. Is equal to this one stays there, OB minus OC. So I've just transposed. So you can find out that CB is OB. So the same order, looking at this and look at this, It's in the same order. So if I have a vector that is empty, yeah, it's going to be OT minus OM. This is looking at the same pattern. If the vector is Serecunda and Carnifine, that's here. So I have OK minus OS, simple like that. So now you can find if it is America and let's say America and Britain, yeah, AB, right? So it's also going to be OB minus OA. So it's cool like that. So this is the relationship between the vectors. So when you're finding the position of the way to the key points, the key. First, you must know that the position vector of a vector, if the vector is P, its position vector is supposed to be OP. Yeah, that is rule number one. If the vector is P, its position vector must be there. And number two, if the vector P must be also equals to OP. Understand that? That's another rule you have to figure out. And rule number three, if the vector is PQ, then I have to ensure that it is OQ minus OP. So these three important rules, these are the three rules you're going to use to solve the problem. So watch out. I said that if the vector is pen, then its position vector is open because it's always relative to the origin, and the pen must be equal to the open. Remember that? And I said that if the vector is PQ, then its position vector is supposed to be OQ minus OP. So I'll take it from the back, OQ minus OP. From this analysis, you'll be able to know how I got to those three simple points you have to look at. So if the vector is P, then its position vector is OP. So remember that if the vector is G, its position vector is OG, and the G must be equal to the OG. If the G is a bottle of water, then OG must be also a bottle of water. That is what we mean by OP must be equals to P. That is the vector is equals to its position vector. Watch out for that stuff, and we will also look at how the third rule comes in. Yeah, if I'm coming to find the position vector of 2 points, then the second point minus the first point. That's what we go. So now looking at those three concepts, we must now go to the exam questions as we move along. So let me clean the board away, push there. So